we're about to get into our systems of equations and systems of inequalities and things like that. But first of all, we need to understand what a matrix is, because we're going to use matrices in order to solve our systems of equations and things like that. So a matrix is it's just a rectangular list of numbers. It's just a way how we list numbers. We could list coordinates, and then we can do some calculations with our matrices once we have a matrix drawn out. And some things to know: a matrix has rows and columns. So rows go this way, left to right, and columns go up and down. So in this case, we have row 1 right here, and we have row 2 right here, column 1, column 2, column 3. Whenever we name the dimensions of a matrix, we always start with the rows and state it by the columns. So this would be a 2 by 3. This would be a 2 by 3. And you have to know that, because when you type these into a calculator, you have to state what type of matrix you want. And so in this case, if I was going to type this into my calculator, I'd have to state that it is a 2 by 3 matrix. And what you'll see in the book too is that if there's a subscript with it, that indicates which spot that value is in. So for example, if I look at this A with the subscript 1, 1, the first number represents the row number. So this is row 1, and this would be column 1, right? So row 1, column 1. Where if I look at the next one, we got row 2, column 1, right? It's in row 2, but it's still in column 1. So the first number is the row, right? These are all the rows, 1, 2, 3. And the second number is the column. If you notice, these all have column 1 because they're in the first column. These all have column 2 because they're in the second column. So when you see the subscript, that's what it means. So it's not A subscript 32. It's row 3, column 2. That's what they represent that by. And we could also use a matrix to write ordered pairs. So for example, right here, if I'm going to write ordered pairs into a matrix, I want the x's to be up top and the y's to be in the second row. So x is in the first row, y is in the second row, and then it has each coordinate. So right here would be the first point, this would be your second point, and this would be your third point, as you can see up here. So here's the point 2, 3, and the point negative 4, 1, so on and so forth. So we see that. So always put your x's first, and then your y's, and the points should match up. And let's just look how we type this into a calculator, just because when we get to tomorrow, we're going to use our calculator a bunch for this kind of thing. And if you notice in the blue right here, it says matrix. Okay, so this is where we're going to do all of our matrix types of things. So I'm going to click second, matrix. Okay, and first of all, this is where it lists if you want to select one of your matrices that you type in. This is what you would do under the names. Math is where it's going to do some computations for us, and we'll get into that in a while. And edit is where you actually type in the matrix. So in this case, I'm going to change matrix A into what I want this to be. So this is going to be matrix A, what I'm going to type in here. So in this case, what is this? This is a 2 by 3, right? 2 rows by 3 columns. So I got to hit 2, go over, by 3, enter. And then you should see it's got 2 rows and 3 columns, right? A 2 by 3. And then I just type in my information. So 2, negative 4. So there we go. I got it typed in. So matrix A is going to be this matrix right here. So if I'm ever going to use that matrix A, I'd have to go into my matrix option, right? Second matrix. And then I'd select this, matrix A. And if I hit enter, it's going to post that matrix. Okay. And then there's lots of things that we can do with this. But just to get a sense of how to type it in. So make sure everything that we do with our matrices is going to be in this matrix option right here. So second matrix. Remember, edit's where you type them in. Names is where you grab them to do operations. So for example, let's say I wanted to represent this quadrilateral with a matrix. Well, what I would do, let's take a look. I have 4 total points. So this is going to be what type of matrix? A 2 by 4, right? Because the 2 is going to represent my x and my y values, and the 4 is going to represent all 4 coordinates. And then would the order matter in this case? Yeah, I would say so. We should go alphabetically. So I should put A first, which is the point 2, 3. So 2, 3. Then I should put B next, which is what? 4, 1. We'll kind of fly through this here. And then we got 3, negative 3, and negative 2, negative 1. So A should be here, B, C, D. So I could type that quadrilateral into a matrix, okay? Just kind of showing you how we could use our coordinates there. All right, so now let's start using some other types of representations here. So it says assume you only have 2 choices where to buy groceries. You can only go to Cub or only go to Rainbow. Those are our only two options. Okay, and we interviewed shoppers coming in and out of the two stores. And what they said was 90% of the 200 Cub shoppers that we talked with say they'll return to Cub the next week. So what does that mean with the other 10%? Where would they end up shopping? Yeah, that other 10% are going to end up going to Rainbow, right? Because they can only go to either Cub or Rainbow. That's what my last statement just was. Okay, so 90% are going to return out of that 200, and 10% will go to Rainbow. Whereas at Rainbow, 85% of the 250 shoppers will return. So that means what percent is going to go to Cub? Well, that means 15% is going to Cub. And how many total shoppers do we have in this case? For a total of 450 total shoppers. Okay, that might be helpful to know. I like to write things down. All right, so what I can do with this information is what we call a transition diagram. Okay, so we have two options here. Sometimes you can have more than two options, depending on your situation. And so I have Cub, and you see how I kind of have this circle that's coming back into Cub. So 90%, hence my 0.9 right here, are coming back into Cub. But then the other 10% of those are going to Rainbow. So I need to put 0.1 right there because 10% of those are going to Rainbow. Whereas for Rainbow, we have 85% are returning to Rainbow, which we had right here. And then 15% are now going to Cub. So 0.15 for that 15%. So that was 15%. This is 1%, 10%. Whoops. So those are the numbers that are missing. This 0.1 right here that are going to Rainbow now, and this 0.15 that are heading to Cub. So how many people will be shopping at Cub next week, and how many at Rainbow? So let's go back. So let's look at Cub. I had 200 original shoppers at Cub. So let's do Cub here. So we had 200. And now 90% are returning. So I would multiply that by 0.9 to get those that are returning. Plus we have to add on the ones that left Rainbow that are coming to Cub now. So what percent left Rainbow and are coming to Cub? What do we figure that out? Right here. 15% are leaving Rainbow and heading to Cub, right? Because 85% are returning to Rainbow. So then I'm also going to get, out of those 250 that went to Cub, 15% are going to Cub now. And I can just multiply and add there to figure out what's going to be at Cub next week. So we get about 217.5. So I'm just going to write that as a decimal here, 217.5. And if I did Rainbows now, well, it was 85% of the 250 are returning. And 10% of the Cub. Well, let's go back up to the Cub, and let's round that. Instead of saying 217.5, we'll say 218. Well, how many would that leave for Rainbow? Well, there was 450 total, and if I subtracted that 218, I'd be left with 232. So 232 shoppers would be at Rainbow. So I wouldn't even have to technically type that in. I kind of did that mentally there because I know there's 450 total shoppers. What about 2 weeks from now? Well, now I'd have to do the same thing, except I'm going to use my new information. So I'm going to do with Cub again here. So now there's 218 shoppers and 90% are returning, plus 15% are coming over from Rainbow. Well, what's my new Rainbow total? 232. So 232 plus I'm gaining 15% of those. And I'd have to go ahead and calculate that again. We got 231. So 231 shoppers are now at Cub, which would leave how many at Rainbow? Well, there's 450 total, so 450 minus 231, which would put us at 219. So now there'd be 219 at Rainbow. Then it says, what about the long-term value? Interesting, the long-term value. Well, I'd have to keep going. I have to take my 231 shoppers that are now at Cub and multiply by 0.9 and add that to 15% of the 219. Then I'd have to keep going. So I would just take that. This is my new amount for Cub, so I'd multiply that by 0.9 plus, well, how many would be at Rainbow now? Well, there's 450 total, so 209.25 if I guess I'm using a half or parts of people. So if you notice how originally it went from 200 Cub to 218, so we had an increase of 18 customers. And then the next week it went from 218 to 231, so an increase of 13. And now as we get further and further, it increased, about 4 or 5 customers and then 3 customers. Pretty soon it's not going to increase any customers. Well, there we go. I finally found it. I took 90% of 270 and added the 15% of the leftover 180 that are at Rainbow, and I'm still at 270. So that would be my long run value. That took me a little while to get that, but 270 at Cub. 270 shoppers and 180 at Rainbow. So originally we started with 200 at Cub and increased to 270. And we started with 250 at Rainbow and decreased to 180. So that's some type of like market research. That's somebody's job. They would do that. They would go to places and interview and see what kind of percents are returning or were more likely to buy certain things. And then they calculate, and that helps to decide, how much inventory they need or how much more marketing they need to do or all kinds of different stuff. So this is where like a mathematician would have like a real life job as a market researcher. And what we can do with this as well is we could put this into a matrix if we would like to. So for example, for the Cub, there were 90% that are returning to Cub and 10% of those that are now going to Rainbow, whereas for Rainbow, 85% are returning to Rainbow and 15% are now heading to Cub. Okay, so that's the one way you can organize it into a matrix. I know it's kind of confusing, but we'll show you how we use that eventually. All right, so basically just kind of an introduction on our matrices and our transition diagrams.